Hello students, in the previous class we have gone through integration by substitution, and we have taken we have considered few examples. We have gone through what are the kinds of how we can go with the substitution. There are three ways to go with the substitution. One, the direct substitution, other is the moderation, then substitution, then after assumption with the substitution. These things we have gone through in the previous class. But today I'm just proceeding with a few more examples so that you can make yourself very much comfortable with the substitution. So I'm taking here example number 1 for today, and this is, let us suppose you are having 10 to the power 4 x dx. How we can go for? First of all, we write on I. This can be written down 10 square x, because directly it is not substituted, so we can write like this, and 10 to the power 4 can be written like this, and I am writing. After doing so, this is 10 square x, we'll leave as it is, and we'll change it sec square x minus 1, because this is a formula for 10 square x. Earlier we have gone through in the identities. Now I am making in the two part. One is 10 square x in the sec square x dx. Other is minus 10 square x dx. So we are getting the two parts. Let's suppose this is I1, this is I2. First of all, we will go with the I1 so that we can get the I. And here it is. This is 10 square x into sec square x. And here direct substitution is feasible, because 10, when you put the 10, we will have a derivative sec square with the dx. So I am putting here, let 10x is equal to t. The moment we will do so, after differentiating, it will be sec square x dx is equal to dt. And the complete conversion will be there, t square dt will be there. And that will be t cube by 3 plus c. 1 you can write like this. And what is t? You have assumed t is a 10. So it is 10 qx by 3 plus c1. And this is number 1. Further we'll go with the I2. Here there is no substitution like situation. Simple 10 square x is there. That we can solve it by trigonometrical moderation. How we can go for sec square x minus 1. So these are the two parts. And both the parts are now integrable. Sec square x is a simple dx minus dx. So difference integral for sec square x will be 10x. So this is I2 is equal to 10x minus x plus c2. And then we'll club for I1 plus I2 will have, and this is 10q x by 3 plus c1 plus 10x minus x plus c2, and finally we can write down 10qx by 3 plus 10x minus x plus capital C, where capital C is c1 plus c2. You can write down like that. So this is the way we can go with the substitution and with the moderation, and we'll have also trigonometrical part there. I'm taking another example for today. Second, earlier we have gone through the results of 10x, cot x and all. So I'm just taking an example for you. 1 plus 10x is there. 1 upon 1 plus 10x. And how we'll go for? Here there is no visibility of the substitution. So just we write down here. We'll moderate it. I'm moderating it. That is sin x by cos x into dx. And finally it will be cos x upon cos x plus sin x. So after moderation we got this one. But mathematics means always creativity, and by creativity you can substitute and something you can do. So I am doing here. I have taken the consideration, multiplying and dividing with the 2 cos x. We can do so. There will be no alteration in that. And I am doing dx. And we can write down also, this is cos x plus sin x plus cos x minus sin x. The total result will remain same, but we are searching the case of substitution, as well as we are trying to make this integral in the standard form. So we got it. Now after that we will make in the two part. One part will be the half dx, because this one with the denominator, plus half of this is cos x minus sin x upon cos x plus sin x dx. Now both the part, first part is simple integrable, this is half of x. For second part, what we are seeing, there is a derivative in the denominator of the numerator, f dash x upon fx integral sign, and this is dx. So we got half of x plus f dash x upon fx, and this is, there is a shortcut tips here. Whenever you have this one, this is half of x plus log fx plus c. For your knowledge and for your tips, you can write down, since there is a result for that, f dash x upon fx. Whenever you are having this situation in integral calculus, it will be always a log of fx. So this is the plus c, and that situation arising here, and after doing so, we'll put the fx. What is fx? Log of, what is fx? This is sin x plus cos x and plus c. This is the way we can complete this question number 2. So they're very simple. Every time our philosophy is same, we have to moderate the integrand in such a fashion so that we can make it in a standard form. Sometime by trigonometrical moderation, sometime by algebraic, which earlier we have gone through, but this time we are trying to make it in the terms of substitution, as well as some moderation in terms of algebraic and trigonometrical. So the philosophy is same. Either you are doing any part of the integral calculus, every time the situation is same, you have to moderate the integrand in such a fashion so that you can make it in a standard form. I am putting the third example for today. This one, 1 upon sine x minus alpha and sine x minus beta. This one I have. So this is a very peculiar question, and this is very important for the board examination. So I am doing. In this question, there is a tips. Whenever you are having sine, same ratio in the denominator with these angles, always make sine moderation in terms of sine in numerator. What I am doing? X minus alpha minus x minus beta. The resultant will be the same, because x will go out, and only remaining thing will be, you can write down here I. Remaining thing is there, 1 upon sine beta minus alpha by 1 upon sine beta minus alpha by, you can balance it, and this is sine x minus alpha, sine x minus beta, and this. So there we have put it down, there is input sine beta minus alpha, and with the same input I am balancing, so there will be no effect. But why we are doing so? Because our motive is same, we want to moderate in a standard form. So after that, this is 1 upon sine beta minus alpha, and this will open in the terms of sine a minus b result. This is sine x minus alpha into cos x minus beta minus cos x minus alpha into sine x minus beta, and the denominator is and dx is there, as well as here sine x minus alpha into sine x minus beta. Now we'll make in the two terms, 1 upon sine beta minus alpha will outside, and I'm making two terms in this one. First will be sine x minus alpha, sine x alpha will go out. Only remaining will be, when we will go for, this will be integral sine cos of x minus beta upon sine of x minus beta, and this is. In the second part, sine x minus beta will go out, and this time we will have cos x minus alpha upon sin x minus alpha, and this is dx. So after doing so, we are having the notation sin beta minus alpha, because this is constant, it is always outside. This will be tan of cot of, this is not tan, this is cot of x minus beta dx, and this is also cot of x minus alpha dx. And for both 1 upon sine beta minus alpha, and for both, in earlier class we have gone through what is the integral value for cot. This is log of sine of with the angle x minus beta, or minus log of sine of x minus alpha and plus c. So this is the way we can integrate it, because this time we are having integral situation with the cot x. The integral value for cot is log of sin x. Here we are using so, and we got that. So whenever we will have the same sin, we'll make the combination numerator in terms of sin. When we will have mix, the tips, we'll make a cos. So these are the tips, these are the results, these are examples I am putting for you. You just go with that, these examples, try to get it, try to add more and more questions with in your pocket with the substitution, because this is one of the vital part for this chapter, for the integral calculus. If you are having grip on that, again I am repeating, definitely you will have no problem at all as in the CBSE examination as well in the IIT examination, because until unless you are not having grip on the creativity, until you are not having grip on the substitution criteria, it is very difficult to move further. So I am again instructing you people, you just go with the creativity in terms of the substitution and try to get it. So with these three examples, I am stopping myself here only. I will again attach few more questions for you, and definitely it will work able for you. For today, thank you. God bless you.